Good afternoon, students. As we know that we will study ionic equilibrium, today I am going to discuss about the hydrolysis of salts, also known as salt hydrolysis. This will play a very important role in your JEE Advanced, JEE Main and NEET exams. So you need to pay and understand concepts to the basics, right? So, if I talk about salt hydrolysis, one of the basic things which we need to understand is how are salts made. A salt is made basically by the combination of an acid with a base, and thus it gives you salt plus water, right? It gives you salt plus water. Now you understand this sign. This is reversibility, right? This is a reversible sign. Now this reversibility is used only when it gets hydrolyzed. Now if I say, for example, a strong acid and a strong base, if they interact, this reversibility sign goes by a single arrow, right? It moves only in one direction. It forms a salt and water. Now, you can ask me why. This case, when a strong acid and a strong base, I must be knowing that you also must be knowing what is a strong acid and a strong base. You must have studied it the concepts of Arrhenius theory, Bronsted theory and Lewis theory, right? So, if I talk about strong acid and strong base, it gives salt and water. Now students, you need to understand, this salt will never undergo hydrolysis, right? Why? Because this salt is a salt of strong acid and strong base. Let's for example take NaCl plus H2O here, right? Now this salt is basically formed from HCl, which is a strong acid, and NaOH, which is a strong base. Now if I tell you, this salt is formed from this. Now if I tell you, when you dissolve common salt in water, you don't need to understand as a rocket science. What you need to understand is a basic thing which you observe in your day-to-day life. When you put common salt in water, do you get acid and HCl? Or do you get acid as an HCl or a base as a NaOH? Now let's say you are cooking some food and you put some common salt for taste. Do you get an acid and a base for tasting? Right? No, you don't get that, right? What exactly happens is, this salt of strong acid and strong base is highly ionic, and thus it dissolves here in the form of Na plus and Cl minus. There is no weak component present in the term of Na plus ion or Cl minus ion, and thus they do not hydrolyze. What they instead do is they dissolve. They usually dissolve. Now, if I say what exactly happens when I take a case of a strong base, I took a case of a strong acid and a weak base. Let's say somebody might ask me, I can take the case of a strong base and a weak acid, or else I can take the case of a weak acid and a weak base. Now these are not the cases, I am talking about their salts, since I am talking about salt hydrolysis, right? Now students, if you see their salts. Now students, if I move ahead, if you can notice these cases, if I move ahead, let's talk something about hydrolysis. What does exactly hydrolysis mean? Hydrolysis means a salt breaking up in the presence of water and taking up ions from the solution, right? Now if you see from here, let's take a salt. Let's take a salt such as NH4Cl. In the first aspect, when you look at the salt, what things can you decode about it? What are the things which you can, by looking at the salt, you can decode? Here are a few things. If I say this salt's parent acid was HCl and this salt's parent base was NH4OH, I decoded the first point. Now, by decoding it, I understood that this is a strong acid and this is a weak base. I decoded the second point. Now, since this is a salt of a strong acid, it will be dominating over the weak base, and thus the pH of the salt will be less than 7. This is the third point I decoded just by looking at it. I don't even have to touch my pen. Now, the fourth thing which you need to decode is which part is going to undergo hydrolysis, right? Now, understand this. The fourth part is the trickiest, but yet it is the easiest. Understand this. When I tell you hydrolysis, we need to make the salt interact with water, right? Now, if I put it in water, okay, tell me this will be hydrolyzed into its parent acid, that is HCl, and parent base, that is NH4OH, right, students? Now if you check it out, just check once. This is the thing. Understand, when you put a salt, it's a salt. When you put a salt in water, what exactly happens? The water breaks or the salt dissociates? The salt dissociates. So you will write it as NH4H plus Cl minus, because the salt dissociates in water. You cannot break water, right? You are not passing an electricity discharge. Now, if I write it like this, check here. This is the strong part and this is the weak part. Here is where you need to understand. The strong part dissociates. The strong part dissociates in the presence of a base. This is a strong acid. And the weak part hydrolyzes. Right? This is what you need to understand. If you can understand this fourth concept, just look here. Now, this is the strong part. So this dissociates, this furnishes a strong acid in the presence of a weak base, strong base, anything will always furnish H plus, and thus NH4OH. Now if you have a look here, just see, Cl minus was a spectator ion. I could have also asked, what is the spectator ion in the hydrolysis of NH4Cl, ammonium chloride? Immediately we need to write Cl minus. So this was the spectator ion, right? Now if you see, students, the fifth point, this was the fourth point, and now the fifth point through observation, just by writing one equation. If you see, this was the cation, this was the cation, and this is from the weak part, that is the weak part of the base, right? Now if you see, this part is undergoing hydrolysis, not the anion. The cation is undergoing hydrolysis. This was the fifth point. So we can also write a salt of a weak base and a strong acid undergoes cationic hydrolysis. And conversely, students, you can make it out, a salt of a strong base and a weak acid will undergo anionic hydrolysis, vice versa. Now, if I take it from here, you just understand one more thing. Look here. We initially said that the pH is less than 7. How could we say that? We are finding H plus in the solution, in the ionic form. So this adds to the pH, right? This makes the solution acidic. Now students, if I move further from here, if you have noticed this thing and you have kept it in mind, let me now generalize it. What to do now? I am going to write NH4 plus H2O, and this gives you H plus NH4OH, right students? You need to understand one thing here. This is the hydrolysis part, right? This salt is undergoing hydrolysis. So the equilibrium constant will be replaced by KH, right? Now, if I say KH, now KH will be H plus into NH4OH divided by NH4 plus. Students, you might write H2O here. If you write H2O here, you have to write K equilibrium constant, then you can write H2O here. Now since this H2O gets multiplied, I am replacing it by KH, right? This is the basic, you might have understood. Now, from here if I move on, you can see H plus interacting with NH4OH. Now this H plus, if it interacts with a base, be it a weak base, it will interact or pick up the OH minus. Now, in picking up that OH minus, this particular part dissociates, and if I write it here, short, this, due to this H plus, this becomes NH4 plus and OH minus. So if I write this is a weak base, so I write Kb here. If I write Kb, I get NH4 plus and I get OH minus, right? And I get NH4OH, right students? Right? So I will be picking up a chalk again till you look at and till you copy it down. Now, if I replace this NH4OH, what can I write instead of NH4OH? Just look from this equation. I can write KH is equal to H plus into NH4 plus into OH minus. NH4 plus was already there, and then here I write by Kb, right? If I replace NH4OH, you can see if I replace NH4OH here. So now this part gets cancelled, and H plus into OH minus is equal equal to Kw. What you get exactly is, you get H plus into OH minus as Kw. So you get KH is equal to Kw by Kb. Now students, if you see, I can write Kw as KH into Kb, right? Understood? Now, if you see from here, if you can check it out from here, this thing would have been done easily by looking at the salt. How? I can say by remembering this point, the strong part ionizes and the weak part hydrolyzes. If you remember this thing, you can easily do it by looking at the salt. Just see here. In this salt, this is the weak part because it comes from NH4OH, a weak base, and this is the strong part, Cl minus, which is coming from a strong acid HCl. So this part is going to correspond to the KH because this is going to hydrolyze, right? And this part is going to be Kb, right? Isn't it? No, this is where you need to be very important and very sure. The weak part is going to hydrolyze. So the weak part is NH4 plus, which comes from NH4OH, and thus you have to write Kb. This is going to hydrolyze, help in hydrolysis, and this is where you need to put KH. And thus, if you write it, you can immediately write as Kw, right? So now students, if I give you a salt like this, a random salt, if I give it like this, if I give you a salt CH3COONA, right? You can check it out. This is coming from a weak acid, the parent acid being CH3COOH, and this is coming from a strong base, which is known as NOH. Now immediately I can write this salt when undergoes hydrolysis, this will correspond to Ka and this will correspond to KH, and thus you get Kw, right? This was the case of hydrolysis of a salt of strong base and weak acid, which is again an example of anionic hydrolysis. Earlier one was cationic, this one was anionic, right students? You can immediately make it out, so you need to be sure about it. In the next video, I am going to find out the pH and the pOH of these salts.